Hi, so I'm just going to run through some examples of sketching the gradient function. So I've got a couple from Geogebra first of all. It says drag the point with the x to investigate the change in slope along the curve. Why does the tangent line change colour? So that's just another thing to think about. And then I'm just going to, so the gradient is always the height of the triangle. So at this point here, the gradient is minus 5.36. And then notice as I drag it along, that gradient's always negative, right? So then, okay, it changes color around here. Why do we think that might be? And then from here, well, my gradient is always going to be positive, so that's why it changes color at that point. So then we need to think, how can we draw this? And that's where the second bit comes in, the bit that's in sort of purple and green. So if I just put slope function here, ignore it says dy dx equals 0. I'm not sure why it says that, but what it's going to do is start to plot the gradient against your value of x. So you can see here, let's just change it to a bit more round value of x. So let's try and make it minus 4. Yeah, so x is, let's call it minus 4. So my gradient, I can see the height of the triangle is minus 5. So if I look down on my second graph below where I'm plotting x by dy dx, I can see that x is minus 4 and dy dx is minus 5. Let's move it along to where x is 3, or minus 3, sorry. So it's about minus 3 there. And we can see that the gradient as well is minus 3. So at x is minus 3, the gradient is minus 3. And then as I keep moving along, so we know that it's always going to be, my dy dx is always going to be below the x-axis at this point. And then notice there's a key thing that happens here. I think I was just on it before. At x is minus 1.5, dy dx is 0. So that's why it crosses on my second graph below. That's why it crosses the x-axis, because that's where dy dx is 0. And then as I keep going up, the graph gets more and more positive. So as I go this side of the turning point, I can see dy dx is going to be above the x-axis because everything here is positive. So the second graph, the key differences between the top graph and the second graph is the top graph is x against y. So that's the graph of x squared plus 3x, or y equals x squared plus 3x. The one below that is the graph of x, so your x value against dy dx. So that will be, and this line, the one that's in green and blue below, that will be the line of 2x plus 3, because that's what the gradient is. That's what the dy dx is of x squared plus 3x. Right, we'll just have a look at one other one before I go through example 19. So again, just have a look at what's going on here. So everywhere I'm going along here, as I move along with the red, the gradient is going to be positive. So that means that dy dx will be positive, meaning that when I plot it, it will be above the x-axis. So this is actually going to plot them on the same axis. I'll get to here and there's a key point. Think to yourself, what's going to happen there? Then where will the gradient function go? So gradient is always negative, negative, negative. Then there's a key point around here. So what's going to happen there? Try and think about it before I plot it. And then my gradient's going to be positive, positive, positive. Keeps on getting positive. So let's plot it now. And it also changes colour as well, like the last one. So obviously it changes colour there because that's a key point. It's a stationary point. Same thing. Oh, it's a bit harder to get on this one. There we go. And there, so stationary points are in green. I think positive is red, negative is blue. So now let's plot the gradient function. So I can see that it's positive all the way up here. It only didn't come in because of my axis, so really the red line is starting from like up off my page, but here it starts to come on to where we can see the x-axis, and then as we get to our turning point, so I think I'm slightly off it because it should be in green, but we can see that it crosses the x-axis. So then if I continue, now dy dx is below the x-axis. Oh, and now I've gone a bit ahead there. Dy dx is below the x-axis, and then we're at our turning point, so that's in green, and then it becomes positive again. So that's why the function looks like it does, because we've got our turning points, that's where they cross the x-axis. Then where it's negative, it's going to be below the x-axis, and then positive again, so above the x-axis. A key difference between this one and the last one is that I've plotted dy dx and y x against dy dx and against y on the same graph, whereas here, this is why I like this one a bit better, because it shows y above it and then dy dx below it. So I'm just gonna go through question or example 19 just so it clears anything up you're not sure on. So the diagram shows a curve with y equals fx. Curve has stationary points at -1, 4, 1, 0 and cuts the x-axis at -3, 0. Sketch the gradient function showing the coordinates of any points where the curve cuts or meets the x-axis. So what I'm going to do first of all is just draw that out again. So I've got it. So it's -1, 4, -3, 1, and then it goes like that. So what I quite like to do is, a bit like in that first example I showed you, is plot dy dx right underneath it, so you can sort of match key points up with bits of the graph. So first thing I'll do when you're sketching it is look for your stationary point. So your stationary point is where dy dx is 0. So that means that at where x is -1, dy dx is 0. So that matches up with that point there. Then your other stationary point is where x is 1. So dy dx is also 0 at 1. So that matches up with that point there. So first look for stationary points and just draw them on, because that's where it crosses the x-axis. Then what you should do is look to the left of the stationary point. So what's going on and everything here? Well, my gradient, if I drew a tangent, then I can see my gradient would be positive. So all of that's going to be above the x-axis. Then to the right of that stationary point, my gradient is, well, if I drew a tangent here or anywhere along here, then it would be negative. So I know that in between the stationary points, my gradient is negative, so it's going to look something like that. And then there's a key point as well which matches up to the middle of this, but you don't need to know it now for year 1. So we know that everything is negative between the stationary points and everything is positive to the left of the first stationary point. Then to the right of this stationary point, we can see that anywhere I draw a tangent, my gradient is going to be positive. So it looks something like that. And there you go, there's your sketch of dy dx. You may also be able to prove it, sort of just something I thought of as I was going through the question. You know that this would be the graph of x squared x plus 3. So then that's x cubed plus 3x. So then you could find out what dy dx is, which is 2x squared plus 3. So that should be x squared. So that will be 3x, 2x squared plus 3x. Oh no, sorry, I've done that wrong, haven't I? Because it should be the graph of x minus 1 all squared x plus 3. And then if you differentiate it, so you'd have to expand it and differentiate. So ignore that, that was wrong. Because the repeated root is at 1, isn't it? So if you did dy dx, then you should find that you'll get this quadratic here. Okay, if you've got any other questions, then just email me.